Well, sledding, snowboarding, all fun. Sometimes when I'm sledding, I try to snowboard by standing up on the sled. Usually doesn't end well. Oh, sledding is in snowmobiling. I've only snowmobiled a couple times. It's a lot of fun. Can definitely be exhausting, even just riding around all day in the cold. Okay. Well, let's go ahead and get started. Now, I was having difficulty sharing my screen in my geometry class, so let's hope that that is fixed here. Let's try it. Otherwise, we can work around it. Are you guys seeing anything, or are you just seeing a blank, like a black screen? Okay, that's kind of what I thought. Not a problem. So we will take our Schoology tour, look at that stuff, and then we will look at it a different way. No worries. Adapt and adjust. Critical life skill. All right. So again, remember, as far as our class connects go, I'm hoping, it's my expectation that you guys are attempting the assignments and watching the videos beforehand. Like I said, we're going to recap those videos. We're going to go fast. So if you haven't been doing that, it's going to be tough to catch on just by doing the class connects. Again, you can't just do the class connects. You have to do the other stuff as well. So if we look at this week, so we finished up lesson 4, which I'll talk about. There's a review, again, a review answer key. So try this on your own, check your answers, then go ahead and attempt this quiz. After the quiz, again, hopefully you've had a chance to look at lesson 5 and lesson 6. If not, it'll kind of be a quick little sort of recap that we'll do today. Now, I want to remind you again, you can get our notes right here. So I'm going to pick this up again because I wanted to talk about something in the notes. But if here are blank notes, here are my completed notes. So use this again, take this to your advantage. We'll talk about, what it's related to for us today with angle bisectors. So again, what does this word bisector mean? I know we've talked about it before. It means cuts in half. So that each of these two angles are going to be the exact same. And there's two parts to this, because if you look at the second part, okay, if we know that we have a right angle here and we have this distance, well, if there's a right angle and these two distances, BD and DC, are the same, that's another way to prove angle bisectors. So there's two ways to prove angle bisectors. You can either look at the angles and then know that this distance is true, or you can look at this distance that meets at a right angle and say, well, then the angles must be true. So that's something that we have to use, keep in the back of our mind and use to our advantage when we're going through solving problems. And this leads us to, hey, what happens when we find, where do our angle bisectors meet in a triangle? They're going to meet at one single point, and we call this point the incenter, okay? The incenter. Now, it's important to know what are the values or what are things that are true in the incenter. It is the same distance from all the sides. So this side DP is the same thing as PE, which is the same thing as PF. So the incenter should touch each of your triangle sides exactly one time, and it's going to be the same exact distance. Now, again, that can be useful. Say you work for like an ambulance, a hospital, you want to find how can I get to all 3 major roads quickly? Because once I get on the major roads, I can go to wherever I need to be. Well, you should put your ambulance depot, your drivers at the incenter so that they can get to the major highways and get to where they need to be as quickly as possible. So again, using that to solve problems, applying these properties that we just talked about are going to help us. If we keep going, again, that was all what your first quiz was about. And then sort of the other stuff that we were working on. This is the review, okay? Then we started talking about medians and the centroid. So median, again, what does that word median mean? Median means middle. So if I find the middle of this side, the middle of this side, and the middle of this side, and I go to my opposite angle, they're going to connect at one spot, okay? And the important thing to remember about these spots, or this spot, is that it cuts your angle up into thirds. So I have a short third. This is 1/3 of my whole distance. And then if I double that, I get my second distance, AP. So if I think about my whole segment, this whole segment, AE, if the whole segment is 9, PE is going to be 3, and then AP is going to be double that, which would be 6. So little segment 6 plus little segment 3 equals big segment of 9. So understanding, if the problem gives you the centroid, you absolutely know that that middle line is going to be 1/3 for your short segment and 2/3 for your large segment. You know that. Same as if it gives you the medians. If it just tells you, hey, this is equal to this is equal to this, and this is equal to this, well, then I know I'm dealing with my centroid. And so again, using what we know, for example, this problem right here. I know that my larger segment, my 2/3 segment is 8. Well, if this is 2/3 and this is only 1/3, all I have to do is divide this by 2 to get my missing third. So if this segment was 8, this segment would be 4. Therefore, the whole thing is going to be 8 plus 4 gives me 12. So that's what geometry is all about, is applying what we know to figure out what we don't know. And kind of this last sort of center, again, we're talking all about the different centers of a triangle. We're going to talk about the orthocenter. So the orthocenter is a little bit different because it has to be perpendicular to the vertex. So remember, what does perpendicular mean? Perpendicular means meets at a right angle. So if I were to look at this and I say, okay, from my opposite angle to the opposite side, this meets at a right angle, this meets at a right angle, and over here it meets at the right angle. This is going to give me my orthocenter. So sometimes the orthocenter, like in this example, may be outside of your triangle, and that's okay. It's okay to have that. So I would recommend, if I was, preparing for either the quiz or your upcoming test next week, I would keep this sort of in mind. I might even add more information to this so that I can use this to remind myself, hey, the circumcenter is perpendicular bisectors. It's equidistant to the vertices, so the points. It creates a circumscribed circle. My incenter is it is created by angle bisectors, sorry. And that is equidistant to each side. It's the same distance from the sides, not the vertices, the sides. And that creates an inscribed circle. Centroids create the medians, and we just talked about how it splits between 2/3 and 1/3. And the orthocenter is created by the altitudes. We don't quite use this as much, but this is like the center of mass. So let's say that you were going to create a ginormous triangular structure and you wanted to find where's the center of mass so that I can build a pillar to balance it. You would find the orthocenter and you could build that pillar and you could balance this sort of structure. So just another example of like a real life application to that. All right, I know that was quick. Like I said, it was going to happen fast. There's a lot of stuff to review. Any quick questions before we jump into some practice? And again, maybe you'll have more questions after you practice. All right. All right, I'm going to copy the link, post it in the chat. Go ahead, click that link, please, and we will jump into our practice. We're doing pretty good on time, so hopefully we get a decent amount of practice. That. Perfect. Yes, please take care of that. All right, we got five classmates in. That's awesome. I know one is working on something else. We should have about 15 people. We've got 8. Okay. If you haven't clicked the link in the chat yet, I need you to click that link, please.
Are you guys included?
You say that again? All right. Again, we've got 11 people. That's awesome. Let's try to get a few more. Let's see if we can get our last 4 classmates to click the link in the chat and start their practice. If you're watching the recording, I'm going to share my screen and we're going to scroll through the questions. Let's do about 3 or 4 more minutes of this practice. 3 or 4 more minutes. All right, that stinks. We're going to talk about a few of them in a second. Let's go one more minute. One more minute. Again, we've got 12 people in here. There are 15 of us in the meet. I know I've heard from 2. So that means 1 person is still AWOL. All right, let's close that up. Again, good job participating with that. Use this as just sort of like a self-check for yourself. Are we kind of on the right track? Are we struggling? Do we have ideas about the different centers and their properties? Yay or nay? Let's review maybe a couple common missed ones. Let me share my screen. The circumcenter is the in-center of which special segment? That would be perpendicular bisectors. Again, remember, I strongly recommend use your notes when you guys take this quiz. Okay, again, you can remind yourself what those are. Perpendicular bisectors create the circumcenter, which touches each vertice. Okay, this figure is an example. If this angle is congruent to this angle, then this must be an angle bisector. It's going to cut it in half. So again, kind of the same idea. If this side is the same as this side, that's going to be a median. It's the middle. It's cutting the triangle side in half. These are congruence lines, which mean they are congruent to each other. If you've got this right angle right here and it's not going through the vertex, it's going to be a perpendicular bisector. Again, perpendicular means right angle and bisector means cut in half. We just talked about that. That is the circumcenter. All right, so this is in the middle right here. This is in the middle of these, and these are in the middle right here. The one part that's different about the in-center, which a lot of us said, is that the insect center doesn't have to go through the vertex over here. Because it went through the opposite vertex like this, we're going to call it the centroid. Okay, because it went through this opposite vertex. So it's important to look all the way down and say, is each line going through the vertex? Yes or no? Whereas this one, okay, notice it does not go through the opposite vertex. It misses it, it misses it, it misses it, but it does create right angles. So because it creates these right angles, we know that it's going to be the circumcenter, which again would touch each vertex one time. A lot of information here, okay? Basically, I see, hey, these angles are the same, these angles are the same, and these angles are the same. And not only that, but this distance right here is going to be congruent to this distance, which is going to be congruent to this distance, and they meet at right angles. So I know that I found the in-center because of angle bisectors. All right. Good job with that. Let's jump to our Class Connect. Again, how do you find this? This is how you get credit. Because again, you just attending is awesome, but we got to show that we learned something. We got to say, yes, I got something out of this. So go to the Class Connects assignments folder, Click on today's date. We just talked about this one, okay? Or something similar to this. If AC equals 16, okay? This should say AP. AC equals 16. What is AM? Again, what do these congruence line means? It means that this side AM is the same as MC. So think about little angle plus little angle equals big angle. And if they're the same and they have to add up to 16, how much is this going to equal? Over here, point O is the circumcenter, okay? That tells us a lot of information. Find OB. Find OB. So if I say that, okay, if this is the circumcenter, I know that this side is 4, this side is 6, and this side is 5.1. Let me double check on that one. That one, I believe the answer is 6. Let me double check. That one's kind of a goofy one. And then we actually went over these already. Again, what's the center of this one? If it's got a median and it goes through the opposite vertex versus, hey, it's finding the middle and it's meeting at right angles. That one's going to change. Okay, so go ahead, fill those out to get your credit. Like I said, I'm going to double check number 2 right now. Number 2, the answer was 6. So again, let me just pull that up. Why I couldn't think of it at the time, I'm not sure. The reason is that these distances, okay, this distance right here, C to O, is the same as A to O, which is the same as O to B. So if we know that CO is 6, then OB also has to equal 6. I apologize, I had a little brain fart. As you can see, these can be very easy to mix up, and that's why it is important to keep your notes by you, take your time, show your work so you don't make those silly mistakes. All right, that's all I've got for you. Get that filled out. Let me know if you have any questions. We'll meet next week, same time, same place.